So I understand that Brian here has a hammock of love.
It's
And
the hammock of
I don't know how many of you visited it, but last I heard it was the hammock of self-love.
Right.
Okay, anyway, this is Shawn Mills from Hack My Solar. Are you still doing that project?
Yeah.
Okay, Hack My Solar.
The website's not a thing anymore, but I'm still doing the stuff.
This is the man that made like solar understandable to me, and as you can tell, I've implemented all sorts of panels all over my property. But the solar water heater is badass, and panels are in the future.
Yeah.
But yeah, anyway, so what are you talking about today?
Just solar. We're
Solar?
talking about solar
Just
stuff.
solar.
Just solar.
Anyway, I'm gonna hand the mic to him, guys. I need to go take care of some stuff down there, so you can stop the live stream when we're done. Here you go.
All right, thanks.
Take it away.
Britney Spears mic.
That's the live stream, baby.
All right.
You know you gotta sing it.
I'm gonna sing it. Yeah. All right. So what we're talking about today is solar. So we'll talk a little bit about photovoltaic. We're going to talk about thermal. I'm going to try to demystify because most of the time I get the same questions. Now I know some of you guys have seen some of my presentations before, so I'm going to try to add some new stuff as well for us to talk about. But that's generally what we're talking about. So I want to start with laying down some kind of just general things that are always going to apply as ground rules, so to speak. So watts is always going to be the number of amps you have times the number of volts you have. So when you are talking about, hey, I want to run solar, but I want to put it like 600 or 800 feet away from my house, what is that going to do to my wiring bill? Well, if you increase the number of volts and you have the same number of watts, by definition, you're going to decrease the number of amps. And so the thing that you always get concerned about when you're talking about long runs is the current, right? It's the flow of the electricity, and current is what's measured by amps. And so a lot of people are really surprised when I say, yeah, if you kick your voltage in that wire up to about 600 volts, you can run 1,800 feet and still only have about a 2% loss. I'm like, wow, that's crazy. But if that amperage goes high, what happens is that electricity starts being converted into heat in the wire because of resistance, and then you have problems. And those problems can just be as simple as you're losing some of your generation, or it can be as serious as fires. Okay. So that's kind of a good general rule of thumb to remember when we're talking about this, is that we can adjust one of these up and the other one's going to go down by definition. So when we're designing a solar system, where do we want to start? Everyone wants to start with panels. You never start with the panels, right? You always start with the usage. What am I actually going to be running on this system? And I tell everyone, it's way cheaper to reduce the things you're going to use electricity for than it is to have enough solar to take care of all of those things. I've been asked the question before, hey, if I don't want to do any kind of lifestyle design at all, I want to run all my stuff all the time, never have to think about it. Can I do that? Can I go off grid? Absolutely. It's just going to be very expensive. And so, this system can do, it's not special. The electricity that comes out of a solar panel is not special. It's the same stuff that is here. It's just being generated a different way. Okay. So we always start with the usage. What are we going to use the system for? Maybe it's just a little well pump, or maybe it's the whole house, or maybe it's a room in the house.
USB rechargeable devices.
Maybe it's just USB rechargeable devices. So once you have that information, the next place that you go, so let's just say, and one of the things that you'll hear a lot is things like watt hours and amp hours. And so again, it's the same thing as like miles per hour, right? You're just taking a unit of measurement and a unit of time and putting them together. And so when we talk about batteries, we are typically talking two numbers. We're talking voltage and we're talking amp hours, right? The rating, how much energy can we pull out of those batteries before they don't work anymore. And so we're like, okay, well, we always use the light bulb analogy, right? So if I've got a 100-watt light bulb and it's on for 1 hour, that's 100 watt hours. Okay, and because I know that amps times volts equals watts, if I take my watt hour number and I divide it by the voltage of the battery, the result is amp hours, which is what the battery is rated in. Okay, so if I'm building a battery bank with a 12 volt battery bank, or I take 2 of those batteries and put them together and build a 24 volt battery bank, I halved the amount of amps that I now need to pull through there because I doubled the amount of volts. Okay, everyone clear on that? So battery, all right, I've got X number of watt hours because I've done my usage analysis and I know now, okay, this is what I want to run on this system. So what I'm trying to do here is I'm trying to build my battery bank so that if I get 1 or more cloudy days in a row, where I'm still going to generate some, but essentially I'm trying to build that battery bank around however many days of autonomy I might want for that system. And so again, it's all math. If I need 1,000 watt hours, or rather 1,000 amp hours worth of battery, once I've done this math, and I want 2 days of autonomy, then I need 2,000 amp hours of battery. Okay. Once I know how much battery I need for the system and for the usage that I'm going to have, the next place I go is, okay, how many solar hours do I have? And this is where it can start to get a little bit confusing, because you're not going to use the exact same appliances the exact same way every single day of the year. In the summer, if you're in Tennessee, you're probably going to want to run some air conditioning or at least some fans. Those are things you're not probably going to be doing in the winter. Now, the difference is that you're going to have more sun hours in a day during the summer versus less in the winter. So that's where you can kind of, the artistic part of putting the design together comes into play, where you're thinking about my usage curve versus my generation curve. And the usage curve versus the generation curve is the biggest reason why we aren't like all on solar or all on wind. Like the reason why we're still burning coal for electricity is because it's reliable. I mean, once that boiler comes on, it produces until you turn it off. And generally it produces in a pretty predictable range. And that's not the same with photovoltaics. With photovoltaics, I need a very specific set of circumstances to come together for me to start generating. And if any of those things get impacted, I mean, it could literally be a blade of grass that's grown up and is in front of the bottom of one cell on a panel, and now that whole panel and potentially the rest of the array is generating at less capacity than what it's capable of doing. Okay. So once I know the solar hours, and the best place to get that is a website called PV Watts. I think it's pvwatts.gov. It's part of the NREL. But you put in your address and it'll pick a spot close to you and give you the latitude and longitude. Say, okay, this is the closest place where we have the data set for you. And it will go so far as to give you all 8,760 hours per year and what you can expect to generate every single one of those hours for that location. Okay. So now I know what I'm running. I know how much battery I need based on my circumstances. I know how many solar hours I have in that area. So now I get to the solar panel. So again, everyone wants to start there, but really the only thing that we're doing with the solar panel is replacing the energy that we take out of the battery. Like that's the point, is to recharge the battery. And so again, if I've got, let's say I'm planning on using 1,000 amp hours of electricity at 12 out of a 12 volt system, what I'm doing then is saying, okay, I take that number and divide it by my number of solar hours that I get. And when I'm talking about solar hours, I'm not saying how many hours is it from when the sun comes up to when the sun goes down. It's a unit of measurement that's going to tell me in a given day, I can average X number of hours of production at 100% for that panel. So let me break that down a little bit. Most of Tennessee is 4.5 sun hours per day on average. And again, that's different, but on average over the course of the year, it's 4.5. So that means that if I have a 100 watt panel, it's going to generate, basically 450 watts that day. And so what happens is when the sun comes up, you start generating a very little bit. And then the closer you get to noon, the more that generation goes up. And then afternoon, it starts going down. And then until the end of the day, until there's no visible light left, it's generating a little bit of electricity. But that is what that looks like, okay? So that would be equivalent to 4.5 hours times whatever the nameplate capacity of the panel is, or the array. So does everyone get, can I expound on that, on what solar hours is? Does everyone get me there? Okay. So again, it's just math. At that point, I know, okay, this is how many average solar hours I get. I multiply or divide that into the number of watts that I need to put back into the solar panel or the battery bank, and I end up with the number of watts of solar panels I need. And then I'm just looking like, okay, where's the best deal? Is 400 watt panels the best deal? Can I get a better deal on 350 watt panels? And I, say, okay, 400 panels is the best deal. 400 watt panels is the best deal. How many of those do I need to get whatever the results of this math equation is? And now I've got my system. There's a little bit more work involved, but those are the primary components of the system. Balance the system are the things like the charge controller, the inverter charger, a generator to top me up if I've got a long period of time without reliable sun, my wiring, my conduit, any connectors, and then my mounting or racking. And so the charge controller is really the one that can mess your system up, because again, we know how many watts we need from our panels, but each one of those panels has a voltage rating and it has an amperage rating. And so I'm putting those things together. So I might say, okay, I want 3 panels that I'm going to wire in parallel. That's going to keep the voltage the same, but it's going to increase the amperage. And then I'm going to have 3 more that are wired the same way. And then I'm going to take those 2 arrays and I'm going to wire them together in series, which is going to keep the amperage the same, but it's going to increase the voltage. And so all of those inputs have to be matched to the charge controller, because if the charge controller is only rated to take 25 amps in, and you just wired up a system that's got 30 amps, well, again, when we have too many amps, we have things like fires and we have things like failures. So,
know anything about that?
What's that?
Wouldn't know anything.
Would not know anything about electrical fires.
So, how many amps would it take to kill somebody?
I think
Really?
I was gonna say, I think it takes 1,000th of an amp to stop your heart.
How many amps you're playing with on your typical photovoltaic system?
A typical system is probably going to be in the 20 to 30 range.
So don't F up.
Yeah. Don't accidentally complete the circuit. As long as the circuit's open, there's no danger, right? But you don't want to accidentally complete the circuit. You don't want to be the completion of the circuit. So yeah, that's kind of generally the steps that you would go through when you're designing a solar system. Like I said, there is some art to it. There is some lifestyle design to it. If I'm going to be running a microwave, then I probably want to do that in the middle of the day when the sun's out versus relying on the battery power to do it. One of the things that you hear me say a lot is you definitely don't want to accidentally turn electricity into heat. But if you can avoid it, you don't want to on purpose turn electricity into heat. If you have the ability to, and you're looking at doing some sort of off-grid system, I'd say cook with wood or cook with natural gas or propane, whichever one you have access to. The electric stove and an off-grid cabin do not go together. Okay, so let's talk a little bit about thermal. So solar thermal, we're talking about heat now. This is where you get the quickest payback. And so any of you guys that did the property walk with Nicole and saw that solar water heater that she has out behind the house, and that thing is not optimized at all. It's like thrown together. It's angled away from the sun. And that thing paid itself in 1 year. And that was with more expensive tubing on the inside than what we had initially thought we were going to put in there. So with material costs doing what they're doing, maybe that becomes a 2-year payback. And the good news is that even if that wood rots, even if the insulation gets eaten by mice or anything else, it's still going to work a little bit. But to buy those replacement parts to put that together, you know, even then that's something that you probably don't have to do for 5 to 10 years. And again, the thing's paid for itself 5 times by then. Yeah.
So I got a quick question. Whenever you're talking about your thermal, so usually hydronic, the total like 100% hours, what do you call it, the 1.5 hour days for solar, is that change if you're using like a evacuated hydronic or water cylinder? I'm talking about
No.
for heat collection. So you have your panels for heat. You also have your evacuated cylinders with reflectors,
Right.
Evacuated tubes. Is there going to be a difference between the photovoltaic, how they're absorbing whatever they're absorbing, and the thermal collectors? Is there going to be a difference in hours?
Yes, because this is based on visible light, and the thermal doesn't rely on visible light.
So you end up with maybe more hours in the day than what you would for photovoltaic.
Yeah.
Okay.
Yeah.
That's cool.
You also get helped by the ambient temperature outside, you know.
Yeah.
So at night, if it's still warmer outside than it is in your well or wherever you're pulling your water from, then even then you're going to get the system's going to be helped. So we've got a recirculating pump in the coal system, and so what that does is it takes the water from her old tank water heater and runs it through that solar thermal heater, so that what happens is that when she turns on her tankless water heater, it pulls from that tank rather than pulling from the well. And so, you know, generally she's getting about 25 to 35 degrees in gain before that water goes into the system, so she uses less propane. And I mean, she could do it without the propane, right? The water wouldn't be as warm, but she could do it. The other thing that she could do is she could turn the recirculating pump off and let the water get really hot in the panel, and then use it. So if she needed to, sanitize something, I mean, that would be a way that she could do it. You could accidentally create a steam bump when you do that. That's why there's a pressure relief valve. But if she needed water hotter than what she was getting and the propane was out for some reason, then that would be a way to get hotter water.
I was thinking more one. So do you want to have that as I'm trying to think about the best way to say this. You said there's pressure relief valve for the solar collector, in case it gets too hot. And then obviously you're going to backfill with whatever you're using, your well water, spring water. What if do you not ever want to like do it as a closed system where it's just a loop, or how do you work around that? Are you always just utilizing your standard domestic cold water as your pressure source for that, and then have a blow off valve for stuff that's too hot?
Yeah, you could do that. You typically want that recirculating pump. So if you're not going to recirculate the water, then you need to only use it when you're like right there it'd be like leaving a pot of water on your stove, right? You're not going to just set it on, turn your stove on, and go to the movie theater, right? So it's kind of the same idea when you're concentrating that heat into the water because you're not circulating it. You want to be there. You want to be able to manage that. So the other way that you can use thermal, so there's active and passive thermal. And so the other way you can use thermal, you probably heard about people, they'll design their house with a slab in the front and a big picture window and an overhang on the roof so that the summer sun doesn't heat the slab up, but the winter sun comes in, and it does. So our off-grid place, actually, if you're looking down on the house, and this is south, I know I'm not supposed to draw it like that, but that's how I started, so I'm going to keep going. So if you look down on the house, that's actually the profile of the roof. So the peak of the roof overhangs 8 feet from the actual structure, and then the bottom of it overhangs 4 feet. So what that does is if you're, again, looking, so we're going to kind of look through the house here. And so what happens is that the shadow that's cast by that peak on the summer solstice, which is the longest day of the year, that shadow will kind of walk around like this, and it'll almost touch the front door, and then it'll go back. right? So what that does is that it shades the front of the house. And I mean, the guys that built it I would never even thought like, oh, all you need is a peak because the shadow is going to move as the sun moves through the sky. But yeah, so what happens is that in the winter we get sun directly on the front of the house, and it helps to heat the house up. But in the summer, the front of the house is shaded because of the way that peak is built. So that's just an example of managing the solar thermal, right? You're gaining it when you want it, and you're not gaining it when you don't want it. And so we talk about, your solar hot water heaters is typically a 2-year payback. If you were to do something like build a little small air heater in the house, that's less than one typically. And so that you've seen like where they take the cans and they cut the bottom out and they put those together. That's what we're talking about here. That's a horrible way to do it. The best way to do it is with 3 layers of black screen in the same size thing. And what happens is your air comes in, it moves through the screen, which has been heated up by the sun. That heats the air up, and then you push it in through your house. I know guys in the Northeast that literally do 100% of their water and space heating with solar thermal. And it's like they don't have a solar thermal water heater. They use the air, the hot air when it's coming in. It heats the water first and then heats the house. And so that would be an example of active, whereas passive, like I said, is where you're just picking up the gain. So the life hack where you put the black barrel of water in your greenhouse so that it gets heated up during the day. And what are those things? Wafadis. I guess that's kind of the idea there as well, is to utilize that solar gain throughout the day, and then it radiates out into the greenhouse through the night so that your stuff.
Actually, Wafadis are designed to not need that.
Okay.
He is actually, the first one he built was actually built north facing to prove that he didn't need the sun.
Nice.
They are not actually built for that passive.
It's the earth, right, that's
Right.
doing the job. Sure.
Yeah.
Makes sense. All right. So with that, I mean, those are the main points. I always get tons of Q&A. So over the years, I've taken these presentations from 45 minutes of talking and 15 minutes of Q&A to essentially I just try to hit the main points and then open it up. So open for questions now. You guys can get specific.
The air heater that you spoke of, that's just recirculating into your air, right?
Yep.
Why is it that I've noticed, as I've had a year now to observe our system, the hotter days, less efficiency off the panels? What's the heat doing?
Yeah, so what the panel is doing is it's essentially funneling a bunch of really excited electrons that come together through the photovoltaic process, and it's kind of collecting those and sending them into the house. So the problem is that when the panel is hotter, those electrons are already really excited because they're hot. And so that's literally what it is. I mean, that's kind of explain it to me like I'm a way of saying it, but that's really what it is that they're already excited. And so less of those jump into the electron stream, so to speak, that goes to the house.
Don't cross the stream.
Do not cross the stream.
Can you explain just grid tied versus not grid tied, and someone who just wants solar as a supplemental backup versus actually running full time, like different systems?
Right.
I think it seems like there's different ways.
Sure.
It depends, right, and how you want to put the system together.
Yeah, so let me touch on grid tied versus not first. And so with a grid tied system, you're typically dealing with higher voltages because that's what the invert is, a different type of inverter. And really the only thing that inverter is doing that's special is if the grid is down, it's making sure that nothing gets from the panels onto the grid. And that's for the safety of the linesman. So if you're in the neighborhood and you're there to fix the power lines, they're supposed to be off, right? And so if someone's solar is back feeding the grid, then you can literally kill somebody. So that's the primary thing that an off-grid, or rather a grid-tied inverter does, is it's designed with that safety switch. There are systems now that will allow you to utilize a certain portion of your photovoltaic generation if the grid is down. And then you've got a hybrid system. So a hybrid system is a grid tied system that also has battery backup. And so those systems can run and do everything that they're supposed to do, whether the grid is up or down. And so, yeah, and the difference is if you're going to do a grid tied system that's kind of just, it's a backup system, right, with batteries and stuff like that. I mean, there, your usage step kind of goes out the door, other than you want to make sure that your inverter is big enough to handle any loads that you're going to put on there. But yeah, I mean, that you can just say, hey, these are the 5 things I want to be able to run if the grid is down, and I want to be able to run them off of battery power, that's recharged by solar. And if the grid is up, then that extra power can just go back on the grid and make my bill go down. Does that answer your other question?
Yeah, I think so. And so some states, I guess, allow that. Others, man, I know we talked about this a little bit, but I'm trying to figure out like what the best.
Yeah, I mean, it's their grid, so it's their rules, right? And so, but it is more. So if you don't have the batteries and you're grid tied, you're essentially using the grid as the battery, right? Okay. You're taking any excess that you're generating and it's going onto the grid. And then, when you're not generating enough, you're taking from the grid. So the grid essentially acts as a battery. Yeah. And there is a cost to that. Now, it's nowhere near what the local power companies want you to believe that it is, but there is a cost to that. Yeah. So the cost to that in most situations is still cheaper than going the battery route. But again, like I said, the problem is that in that non-battery system, almost all grid tied inverters, you're not going to be able to utilize your generation if the grid itself is down. So the one that we put in East Tennessee that was a grid tied system, that was a Sunny Boy, and that inverter specifically allows you to use up to 2,000 watts of your generation. So if you're only generating 600, you're only going to get 600. But if you're generating, 4,000, 2,000 of it you can use. And so those things are coming a long way. It used to be that a hybrid inverter was ridiculously expensive. It was like prohibitively expensive for most systems. The costs of those have come way down. What happened is that you've gotten some UL listed versions that have come in from China. And so that's kind of forced all of the other manufacturers to get their prices into the sanity realm.
So can you have a solar with battery backup and grid tied?
Yep.
So that's the hybrid.
That's the hybrid system. Yeah. And the nice thing about that is that you could put that inverter in with just the solar and add batteries later. You can put the generator. There's some that have a generator tied to it. So there's literally inverters out there that you can go. You can have a wind. You can have a wind tower on it. You can have a solar array on it. You can have a generator on it. You can have the grid on it, and you can have batteries on it. So 5 years ago, that was a $8,000 item. You can get them for less than $1,000 now.
Oh, wow.
Yeah.
Okay. Thanks.
Yeah.
Talk about batteries. What batteries are you using for typical solar installs, and what batteries would you recommend if somebody just wants to build like the Jack style, a small portable or a small power station?
Sure. So you really have 2 options for batteries that are commercially available, and that's lithium iron phosphate and flooded lead acid. Now, the lead acid batteries, you could go to a sealed battery versus a flooded battery, and it's a little bit more expensive, but there's no maintenance. You don't have to add water, and you could throw it in the back of your truck and not have to worry about battery acid flopping out. Okay, or you can throw it in the back of the truck and not worry about getting into a wreck and having battery acid all over your vehicle, right, or someone else. So those are the 2 really the main styles. If it's on a house system, I would almost always, if I'm trying to put in a cheap system, I'm going to go with a Trojan T105 golf cart battery. It's the thing that is the most cost effective. If you want to look at the overall cost of the system over time, lithium iron phosphate batteries are cheaper per cycle. Okay. And so so let's say, for example, a flooded lead acid battery, I'm going to have to replace in 5 to 7 years if I treat it really well. And if I treat it really poorly, I may have to replace it in 1 year. Lithium iron phosphate battery is 10 times more expensive, but it lasts 20 times as long. And I can treat lithium iron phosphate batteries pretty poorly and still be okay. I'm not going to damage them. The nice thing about that is that you get really good, consistent voltage from a lithium iron phosphate battery all the way down to about when it's about 97% depleted. Whereas for lead acid batteries, you literally start up here, and every single bit of electricity you take out of it, that voltage goes down. And so what happens when the voltage goes down? What happens when the voltage goes down?
Amps go.
Amps go up. What happens when amps go up?
Heat.
Heat, right. So I'm really telling people, if you can afford to do it, it's a buy once, cry once type of situation on the lithium iron phosphate.
I know the ham guys, especially the portable ham guys, where they're carrying big batteries in, they like the lithium iron phosphate.
So the one that John was using was a lithium iron phosphate battery, and he likes it because it's the voltage, the consistency of the voltage.
All right, so I'm one of those ham guys. I have a small 300 watt solar system, portable panel, 2 SLAs underneath my desk. They're 79 amp hours. I'm looking for a decent charge controller that does not throw out a ton of noise, and also an inverter.
Mm-hmm.
Right now,
you're not going to get an inverter that doesn't throw off a ton of noise.
Okay.
Try not to put it by your bed.
Literally 4 feet from the
I
bed.
put little
Well, no,
quarter-inch panels and vent holes.
Yeah.
So what I'm talking is radio noise.
Yeah.
Like
Oh,
you put
all
it
right.
on, it wipes the radios out.
Oh, gotcha. Okay.
You isolate it?
Yeah, it's all electrical noise.
So you gotta isolate it?
Yeah, I think you're sitting there doing a bunch of switching, and it's PWM, right?
Yeah.
Yeah, so it's like 2 to 4 to 16 kilohertz.
Yeah.
So you're getting a lot of noise.
So would an MPPT charge controller not do that, Brian? I don't know the answer to this question. I'm not a radio guy.
PTT charge controllers are.
Well, I think- From what I heard, I thought the MPPT went with iron phosphates.
You can. They're not specific. Yeah, they're not specific.
Okay.
If I'm doing a system for someone, I am always going to put an MPPT charge control in there because it maximizes the efficiency of the panels.
Okay. Do you have a brand you like?
For a small system, Renergies are great.
Okay.
The good news is that the more of these manufacturers that are making this stuff, I mean, I know people crap on Chinese made stuff, but the reality is that I'm not going to put a $5 million factory in Wuhan and not turn good stuff out of it. I mean, is it going to be as good as the $28 million factory that's in Detroit? No.
Yeah.
But it's also the stuff that comes out of there is going to be cheaper. It's the same. And, I always also say, always look for UL listed stuff. I mean, it is kind of like it's kind of like the Dolphin Safe tuna. Like it's mostly does what it says it's going to do, but it's better than no rating.
The panel that I have is a Tokyo 300 watt.
Mm-hmm.
It's about the size of a sheet of plywood.
Right. And is it, do you know what the amperage and voltage?
12, it's a 12 volt. I think when I plugged it in, I was getting 12 amps, give or take, and that was behind a tree.
Yeah.
In the morning.
Right.
In Illinois.
So perfect. It's going to be probably in the 25 area.
Yeah.
So you want to make sure that your charge controller can handle those inputs.
Okay. And then if I run, so I'm thinking about running it through where I have my antennas come out. Would 10 gauge work for that?
Yeah.
Okay. Go about 50 feet.
Yeah, you're fine.
Okay.
Yeah. Renergy is actually the wire size calculator I use. So they've got a wire size calculator on their website.
Okay.
And you just put in what your amps and volts and distance is and what your allowable, like, okay, I want to limit this to a 3% loss or a 2% loss or 5 or whatever. And it'll spit out wire size.
Do you work for Energy?
No, I do not work for Renergy. However, if y'all are watching. But no, those are good charge controllers. I use them on smaller systems, and yeah, and their Google search system works well, because whenever I plugged in wire size calculator, they were the first one that came up. It works, so that's one I use.
Right.
Yep.
Would you have any extra considerations for an off-grid setup that some of the batteries and charge controllers and inverters wouldn't be in kind of climate controlled area? Would you do anything differently, or just try to winterize everything before the?
Okay, so that was gonna be the question: is it in use while it's in this area, or is it like you're just leaving it and going away for? Like, are we talking about like a vacation thing, or are we talking about?
We'll be spending more time probably up there through the winter this year, but it wouldn't be year-round, probably through the winter.
So you'll destroy a lithium iron phosphate battery if you try to charge it below 32 degrees Fahrenheit. So if you are not going to have it in an area where you can make sure that it stays above that. Now, most of your battery management systems that come with the batteries just won't take a charge if the temperature is too low. And actually, some of them will use some of the electricity that's in the battery to heat the battery up so that it can receive a charge. So you might want to look to that, or you might just want to stick with the flooded lead acid batteries. Ours are not in a climate controlled area. Now, we have one of the eventual 3 lithium iron phosphate batteries that's going to go in. Those will go in the house. But yeah, we never had a problem with freezing temps. Now, we don't get as cold as it gets up where you are, but we never had a problem with the flooded lead acid. I mean, that's what's in the car that you start, in wherever you are. That's what the type of battery that's in there. So they can take those lower temperatures.
Yeah, I think this past winter, I think I saw as low as -10.
You should be making better life choices. Now, but the nice thing about, off-grid, we're in a colder climate, is the worst thing that you have to design around for a system that's going to be wholly off-grid is cooling, whether that's cooling food or whether it's cooling people. And so if you're in a colder climate, that demand is less.
Could you, so like, I don't know, a typical setup for, let's say here, and you need a refrigerator. I don't know what kind of wattage that would be, like a small fridge or something, or even, I don't know, I guess a freezer would use much more wattage. What would you do? How many batteries, I don't know how you would set it up.
So that's definitely an it depends answer. So the compressor is going to use the same, whether it's cooling the freezer or cooling the refrigerator. So there's no real thing there. The biggest thing you want is something that's not going to pull a lot of load to get turned on. Good insulated. I would say, if you can afford it, and this is another one of those if you can afford it things, a refrigerator or freezer that's specifically designed for an off-grid application, and they make them where they'll run off of 12, 24, or 120, like there's a switch. Those are worth the money. The other option would be a propane fridge. So that's what we had at the off-grid place. Is what's still at the off-grid place is a propane fridge.
And it's exclusively propane. You don't need any electric ignition for it.
Yep.
It can switch to electricity if we want, but we've never needed to.
Yeah, it has a little igniter at the bottom and a pilot light, and it uses heat to cool. I can't describe how that system works. I know ammonia is involved, but other than that, I just know that it works.
You can ignite it by hand, or do you need an electric spark?
You can ignite it by hand, but the system has a piezo igniter or whatever, so you just click and it comes on.
Say, does it safety require electricity, or is it an older one that is a pure propane?
I'm sorry, what?
In the older ones, my understanding is the newer ones, it requires some electrical charge, whereas the older ones use something like a thermocouple or a thermopile to generate its own electricity. I don't know which.
Yeah, no, this uses no electricity. I mean, it can run electricity, but the cooling cycle is all non-electrical. Harnesses, Something to do with evaporating ammonia. Like I said, I don't know how it works. I just know that it does. Yep.
A lot of earthships utilize a kind of a forced air geothermal heat and cooling too. Around Tennessee, do we have radon concerns? Is it spike radon if we implement something like that?
So I don't know all the specific. Radon is definitely a thing here. What I've seen in terms of payback for geothermal is it typically works better in more northern climates. It takes a lot longer to get the actual payback, but it's definitely something that you can do. The best way to do it would be is if you have like a pond on your property and to run it in the bottom of your pond.
For your off-grid, you run that as a 12-volt system completely, or you?
No, the off-grid house has 240. I can run anything. Yeah, and if I pick the right batteries, I can pull 12 volts off of it. Now I won't be able to do that when I go to the lithium iron phosphate battery. I won't be able to pull 12 volts, but I mean I don't ever now. I just have I can because it's the flow lead acid system is all based on 6-volt batteries right now.
Mm-hmm.
Yep.
So,
Go ahead.
No, go ahead.
I was gonna.
Y'all fight and whoever wins.
Yeah, all right. I was gonna go more back to the thermal side of it, so if yours is more mild electrical, I'll let you go.
You're just gonna be a fan.
Nice roll. Okay, so what about, you were talking about, utilize the way your house is designed, you have, where the sun comes in during the winter, doesn't come in during the summer. What about the storage of thermal? Does your house, does it utilize like a cement slab to heat up? Or is it, okay,
so what we have in terms of thermal mass is around the wood burning stove. It's all river rock, like the floor and the walls. And that works, to an extent, but it's not hard to cool, or it's not hard to heat here. We don't get ridiculously cold. So I think we typically ran about a quart of wood a year to heat.
Oh, that's nice.
Yeah, and so it's I wouldn't design the house differently if I was building it from scratch in this climate for that. But yeah, I mean, literally any thermal mass is going to absorb radiant heat and then put it out. That's what heat does, is it goes to where there's less heat. So
yeah,
you don't have to get cute with
like
it.
Some Newton's law or something.
Yeah. Yes, Brian.
So on one of your podcasts, you recommended a series of models of lightsabers to purchase, and I was able to find one of those on Marketplace. Got a screaming deal on it, but it's spent. So do you know of any places I can go have that thing recharged so I can use it in my grid tie system?
Probably Stephen Harris 1, 2, 3. Ship it to him. Tell him to turn his camera on and then open the box, and then you get to see an explosion. Or just buy all the solar panels. Yeah, I'm always worried that someone's going to plug the solar panels in the wrong way and actually like force feed energy into the sun. But it hasn't happened yet. Yeah.
Is that what causes eclipses, or?
Yeah. When someone plugs a solar panel in backwards. Yep. And so real quickly, some people ask this question as well, what's the difference between parallel and series? And so if I'm wiring something in parallel, this is how I remember it. The amps go up. And I remember that because there's more A's in the word parallel than there is in the word series. If I'm wiring something in series, then the voltage is going up, right? So that's how we can take a really high wattage system and run it through 10 gauge cord, is because we get the volts up. Any other questions? All right, guys. Well, I appreciate it. I'm here all today. Thank you.